In today's video, we will be discussing what is discrete data, examples of discrete data, what is continuous data, examples of continuous data, difference between discrete and continuous data. Hey champions, if you are interested in these topics, then keep on watching. You can subscribe to our channel for more such videos. Numerical data, also known as quantitative data, can be divided into two types. First is discrete data, which takes fixed finite values in a specific range, and the other is continuous data, which is exactly the opposite of discrete data and can take infinite values between two distinct points. Let's dig deeper into these two data types to know more about each. Also, we have covered quantitative data in detail in one of our videos. If you are interested in the topic, then the link is in the description box. Let's start with the first type, which is discrete data. As the name suggests, discrete data can only take a finite value in a specific range. In short, only a limited number of values are possible in this type of data. Consider an example of the number of students in a class. This number is always a finite number, which could be 30 or 40 and is generally within a specific range for each school. Discrete data cannot be broken down into smaller parts to make them more precise, and it is nearly impossible to measure between two fixed values. Example, the number of students in a class cannot be broken down into fractions. That is, we cannot say that we have 30.5 students in a class. Discrete data consists of distinct or unconnected elements which are non-continuous in nature. For example, let's assume class A has 30 students and class B has 35 students. Clearly, both the counts are unrelated to each other. Discrete data generally do not change with time. Example, the number of students in a class will not change every month. Under statistical data analysis, discrete data can be easily visualized using bar charts or pie charts. If discrete data is plotted on a line chart, then the graph represents value at specific points along the number line. These graphs do not possess a continuous line but rather only plot points above consecutive integer values. Discrete data is counted and is not measured. Example, you can simply count the number of students in a class instead of measuring it using a measuring device. Discrete data can be whole numbers like the count of the students in a class, or they can also be any other fixed number type such as shoe sizes like 2, 2.5, 3 or 3.5. Some examples are number of students in a class, number of tires in a vehicle, and shoe size. Now that we know about discrete data, let's explore continuous data. As the name suggests, continuous data can take up any value in a specified range. We'll consider an example of the weight of a student in a class. The weight of students in a class can take any value from 30 kg to 100 kg. Continuous data can be broken down into smaller parts to make them more precise, based on the sensitivity of the scale. Example, the weight of the students in a class can be fractional as well, which means that one student can weigh 45.5 kg and the other student can very well weigh 45.45 kg. This type of data consists of connected elements which are continuous in nature. Continuous data generally changes with time. Example, the weight of the students can change monthly. Under statistical data analysis, continuous data can be easily visualized using histograms and scatter plots. If continuous data is plotted on a line chart, then the graph represents a continuous line rather than only points plotted in the case of a discrete data. Continuous data is always measured, and it is practically impossible to count this type of data. They are generally collected from precise measurements. Example, you cannot simply count a student's weight, but you will use a weighing machine for this purpose. Continuous data can be any decimal number. Example, weights of 50 kg, 50.5 kg, 50.55 kg are very much possible. Some examples are weight of student in a class, height of a person, time. Let's summarize everything in the form of the difference between discrete and continuous data. In terms of meaning, discrete data has clear spaces between values, while the continuous data falls on a continuous sequence. In terms of precision, discrete data cannot be made more precise, while continuous data can be made more precise. In terms of nature, discrete data is generally counted, while continuous data is generally measured. For the values, discrete data can only take a finite value in a specific range, while the continuous data can take up any value in a specified range. Discrete data is represented by a bar graph or a pie chart, while continuous data is represented by a histogram or a scatter plot. The last basis of difference is changes with time. Discrete data do not change with time, while continuous data changes with time. That's it for today's video. I hope all the examples made the concept easier for you. You can share your thoughts or questions in the comment box. Subscribe for more such videos. Bye and meet you in the next one.